Hi.
Hello, Katarina. How are you doing?
Hi, Steve. How you doing?
Good, good.
Yeah, me as well. Happy to see you here and happy to see a lot of people joined. So, hello to everyone and welcome to Memgraph's community call. Everyone is saying hi in the chat. Hi there, everyone. It's nice to see so many people show up. Yeah, let me give a small introduction into today's community call. So today we have again Steve with us from Orbit. Let me explain a bit why I'm saying again for those who haven't been a part of the last community call. So last time Steve held a talk on how to build secure multi-tenant GraphQL API on top of Memgraph. And we thought it was a really fun presentation. Everyone enjoyed it. And Steve, your presentation style was awesome. And I think it still is. We talked with Steve a bit further about what they are doing in Orbit for the community search. And we thought it would be really interesting to share the learnings on LLMs that you have. I mean, it's a really important topic and it's quite fun, and people love to learn about it. So we thought, why not to share this knowledge with the community? So today, Steve is going to present a topic is LLMs, Memgraph, and Orbit modeling community networks. And before he starts, let me give a small information about Livestorm that we're in. I see you already know how to use the chat. I love it. You'll notice we have questions and polls as well. So please, if you have any questions for Steve, don't hesitate to ask during his presentation in the questions tab. It will be easier for me to manage it afterwards if you ask there rather in chat, and then I will read them out loud so Steve can answer them. So after the presentation, there will be like a short Q&A session. And also, I will leave a couple of polls in the polls tab. So if you have time, please respond. And you'll get the recording after this webinar. So in case you feel like you missed something, you want to rewatch it, you can do that afterwards. And hopefully that's it. Saying hello to Nicholas as well from sunny Paris, as far as I can see. And I will leave the stage to Steve. Everyone, please enjoy the presentation.
Yeah, thank you, Katarina. Nice intro as always. So yeah, let's get started. Hello, everyone. Thanks for joining this call. So today we're going to talk about how at Orbit we leverage. Let me share my screen quickly. So we're going to talk about how at Orbit we leverage LLMs and memgraphs to model online community networks. So a little bit about myself. I'm Steeve Bete, a senior software engineer. I'm based in Cotonou, Benin, and I like to think of myself as a junior gardener. It's close to a year now that I've been trying to grow strong and healthy bell peppers plants, and let's say it's going okay. Hopefully the next batch is gonna be awesome, but yeah, I'm not quite ready to quit software just yet. I joined Orbit 2 years ago, like over 2 years ago, and there we help community builders grow the community. We have a fully fledged community platform helping with insights, reports, workflows, basically anything to empower community builders. And yeah, so it's my second time on the Memgraph community call. And as Katarina said, last time we talked about GraphQL, and this time is we all about LLMs. I'll start first by sharing the kind of data we have to deal with at Orbit. So conventional data from online communities. Then we're going to see if there is a way to generate fake data, like to fake this data and generate fake communities. And then at last, we are going to see how we can use LLM to analyze the conversations and extract arbitrary properties. Right, so just a quick note before starting. During this talk, I'm going to show a lot of prompts with LLMs. I won't have time to read them out loud, but don't worry because I will share the links to them. So no need to screenshot. You just have to sit back and enjoy. So let's talk about conversational data. So where do online conversations happen? So it's usually the popular platforms like Discord, Slack, Discourse, GitHub, Reddit, just places where people usually get together and exchange information, share things, solve problems, and these kind of things. And for instance, on Discord, you have people can send message and other people can reply. But you can also think of GitHub issues, even pull requests as conversations, because somebody will open an issue, share a problem, and then other members might be able to answer and take action. So conversations are a bit everywhere. And the reason why we care so much about conversation is because they are the very core of communities. All right. So community builders care about them, members as well. So if we want to empower community builders, we really need to harness these conversational data, because relationships are built through conversations. So many things happen there, and they are really rich in information. They are so rich in information that we actually built a product around it called Community Search. So if you are a company using Orbit, you might be able to just connect to your website, could be your documentary website, a widget where people might come and search through the conversation that happened in your community. They'll be able to find like hidden information that could help them, like the issue they had before, these kind of things. So, but in order to get there, we first had to understand or to master the building blocks of conversations, which are messages. So across all platforms, there are usually common fields that you will find. You're gonna find the content of the message, but also the timestamp. So when did it happen? Attributes that come from the source, like if the message is from Discord, it's gonna be a Discord ID, or it could be the ID of a issue or something like that. And then you're gonna have also the type. The type is like which kind of activity we're talking about. Is it a message that was sent? Is it a reply? Is it a new issue? Is it comments? And then also we have the concept of channel on Discord channels, Slack channels, but you can also think of GitHub repositories as channels, right? And then if the message is a reply to another message, you are going to have attributes that references that message. So parent ID, parent type. Last but not least, you're also going to have information about the member, so username, names, these kind of things, and a link to that actual activity online. So these activities, we have a lot of them, and we can now use the references to resolve the activity tree, which builds the conversation. You usually have a conversation starter, like one message, and then that message could have one, zero, or multiple replies, and each reply can have multiple ones. So in general, it forms a tree, and that tree is the conversation. And because a tree is a subcategory of graph, it's the very reason why we went to Memgraph. Because it's a graph database, it's really easy to resolve the connections between these activities, build the edges, and query them. Another reason for Memgraph is it is fast, it was easy to use and install for the team, but it also has a great lab that will allow us to visualize the data. And talking about that, here I picked a random activity, a random conversation, and I tried to include all the activities and the relevant edges just to show what it looks like. So here we have the conversation, and it starts with this activity, and we can see that this activity has a reply, which also has a reply. So it forms like a conversation, like an activity chain or a tree. So yeah, so this is the kind of data we have to deal with. And now that we understand it, we are going to get to the fun part. We're going to try and see how we can fake this data with LLMs. So why do we want to fake the data at first? As developers of community search, it is always useful to have quick data, like something locally, just to get started and just worry about the work. It's also useful for tests to have some data, but most importantly, it's really useful to simulate like edge cases, specific scenarios that are hard to come by in the wild, but we want to be prepared for, like maybe a specific shape of conversations, or I don't know, maybe a specific kind of spam that we want to detect. So yeah, it's quite important to be able to generate the data. So the real challenge here is to generate fake JSON objects that represents individual messages and then have them form conversations, right? So we want to generate fake text, fake source ID, fake authors, but we have a few constraints, okay? So first of all, the conversation have to make sense. but we also need to make sure that the IDs and parent IDs match. A reply must have as parent ID an actual ID of the message it's replying to, and also the timestamps for each activity or in the conversation must be chronological. Like you can have a reply that happened before the first activity. So yeah, usually when we talk about fake data, as developers, we think about the popular tool called Faker. So Faker is like it's been there like for a while. You can use it to generate fake entries, whether it be phone numbers, addresses, fake names, even fake phrases, like fake everything. And it's really powerful when if you care about the look and feel of an app, Faker is going to be really good for you. You're able to fill your page with relevant entries and see how it is aligned, like everything like that. However, Faker is not that good to produce meaningful conversations. Okay, so here I have a small script where I will go through a few members and try to generate um, fake phrases using the hacker jargon of Faker, right? So once we run it, we obtain something that is not a conversation. If you look at individual messages, it kind of makes sense, but together it doesn't make sense at all. Like it is not a conversation. There's no meaning. It's like just a bunch of hackers in a room screaming at each other and trying to sound smart. So we need something that can produce meaningful conversation. We need something that is smarter than Faker, and that's why we need the large language models like GPT. So we are going to use here right now GPT-4 to generate a fake community. But before getting there, we need to think about the kind of community we want to generate, because the more precise we can be about what we want, the higher the quality of the output we are going to get. So in my previous talk, I introduced Alice and Chuck. So Alice had a home cooked food community and Chuck had a fast food community, and they were not the best friends because members from the Chuck community were leaving to Alice's. So yeah, but now we are going to focus about Alice's community, like the home cooked food community. So we want to generate data that this community that could represent the messages this community will exchange online. A few members, just to give some spine to our project. Let's say Alice is the founder, right? She is a big advocate for cooking at home. She supports anyone that wants to cook at home. And we can also think about another member, let's say Molly. Let's say that she loves spices. She knows everything there is to know about spices. And yeah. And then Steve, and a very experienced farmer and very passionate about papers. And then other members, right? The next thing, now that we know the kind of community we want and the members, we are going to think about the platform, like where do we want the activity to take place. And for this talk, I restrained the thing to just Discord. And say we just have like 3 channels, the help channel, the tips channel, and the general channel. So the help channel is the place where people will come to ask for help. Like, I don't know, maybe the kitchen is on fire and then want somebody to help them put it out. And yeah, so the tip channel will be a place where people just come by themselves to give advices and share the learnings. The general channel will be a place where any kind of discussion can happen, like especially planning events and meetups, these kind of things. Right, so we know the community, the members, the platform, but we also have to remind ourselves of the data format, because in the end, we want GPT-4 to give us these JSON that will be the data of our community. And we also need to be careful about the relationship between the different types of activities. So for instance, a Discord message sent can have one or multiple replies. That can also have multiple replies. But if it is a thread, all the thread replies will point to the same Discord message sent. Okay, so now we truly have everything we need to go and cook our community with GPT-4. let's get to work. So for the purpose of this talk, I already went ahead and generated, like had a conversation with GPT-4. I started with just stating my intent. I like to generate some data representing an online community. I specify that it's a home cooked food community. I specify the values and also specify the channels we talked about. I also mentioned the members, but I didn't ask for the data right away. I asked for ideas of conversations. And sure thing, GPT-4 was able to give me some channels, some conversations, some ideas. And yeah, from there, I added the data format, the link between the different types. And after that, it was just a matter of asking for the conversation behind 1, 2, 3, 4, and so forth. So here I'm asking for 1 and 2, it does that. And then 3 and 4, it does that. Uh, After that, I also ask for like additional things, and then 7 and 8, and so on and so forth. And the good thing here is that if you look closely at the data, everything is checked. Like it is a conversation. Like somebody is asking for a sourdough recipe, and then somebody else comes with the recipe. And if you look at the IDs, they do match. Like, so this is the parent, and this is the parent ID, they match. The types as well, they match. So it matches the parent type here. And most importantly, the timestamps as well matches. Here, this first activity happened at 10:20, and this one was 10:45 on the same day. So yeah, like everything seems plausible. So what I did is I grabbed all the different chunks of JSON here and I loaded them in our system. And yeah, here I can show you all the conversations that were generated with the activities. And if you have a look at the results, you're going to see that each cluster is a natural conversation. So you have simple ones with 2 messages. So this one and this one. Also checking like these attributes are the one coming from GPT-4, all right? And you can also see this one, which is a a big conversation, and you can already tell that it's probably a thread because every single activity is pointing to that single one. Okay, now the good thing is the data here, we can actually see them on community search. So I can search for saffron, for instance, and here Molly is able to share some knowledge about spices like the saffron. Somebody replied. I think somebody else had a thing with macaron, an issue with macarons, and people were able to come and help the member that was struggling with macarons. And I think it's probably the same conversation that we saw just here. So just going to check quickly. I'm struggling with macarons. So right, it's an actual long thread. So, okay, it makes sense. One other thing I want to show you, there is Steve sharing tips about bell peppers, how to care for them, how to fight pests and insects and so on. Just the blinds, leading the blinds. All right. Anyway, we saw that GPT-4 did a pretty good job at generating a pretty convincing community. Like conversation makes sense. They are chronological. Everything is good. So this challenge solved. Now on to the next. The other thing we want to do is to analyze the conversations and extract properties using LLMs. What do I mean by properties? So properties are inherent attributes of a conversation. So they are usually answers to generic questions about the conversation. Like I could be asking, is the conversation a spam? Or does it have pointing questions? what are the key learnings, and any answer will be stored as a property for that conversation. And I could be asking like even more questions. What is the title? What is the summary? What is the language? Who is the, I don't know, whatever. So here, just the data is the limit, but we are going to focus on these three. And the reason why properties are useful is because if they are attached to a conversation, they can help with like practical things. For instance, knowing if a conversation is spam is really good for moderation. Like we might want to hide inappropriate conversations from community search. Learning could be something that we use to feed a custom assistant so that people can just come to that assistant and ask a question, and the assistant will use the knowledge of the community to answer. And also knowing if a conversation has a pending question can be like super useful for community managers, because especially if the community is very large across many platforms, like being able to spot open questions can be a good tool for them. So we do need properties. And if we were to ask a human to go through 100,000 conversations and try to manually label every single one with properties, they will go insane. Like they will probably quit the job and it won't end well. So we need something that is smart, but won't complain about this absurd workload. LLMs, we need LLMs. So what we're going to do, we're going to try to feed each conversation with the appropriate prompt to an LLM and try to see if it can output a nicely formatted JSON for us that we can there exploit to extract the properties, store them on the graph, connect it to the conversations, and thus enriching the graph. So that's the plan, okay? And yeah, so we are going to do that. We are going to work with OpenAI again and see if we can generate these properties. So before doing that, I'm going to show you a few conversations that match the various properties I'm talking about. So for instance, for spams, I think one was yeah. So somebody that insists to not be called Chuck is asking people to indulge in fast food. Yeah, but this one was busted. We found that it was a spam already. So let's see another one. So okay, this one, a member that still insists to not be called Chuck is asking you to just order pizza, and he's not looking suspicious at all. I mean, obviously it's a spam. So we are going to try and flag it. The other one would be to extract the learning. So here the conversation about, there is a conversation about somebody that added too much salt, and people were able to give interesting advice to remove the salt or the taste of it. So this one, we want to extract the learning. And for the pending question, I think Molly talked about saffron. So, and somebody asked a question and there was no answer. So we are going to try and extract the properties for these different conversations, all right? So let's get started. So this is the prompt. I have already some presets. So this is the prompt. I'm basically instructing the LLM about, first of all, the data format of the conversation here. So this one is the pizza spam. And then I asking for the properties and also making sure that the format is JSON. Okay, so data format of the input, what I want is spam learning, and then the format. So for this conversation, it is a spam, so spam should be true. There's no learning because it is a spam. And what else? There's no pending question, right? So let's try with GPT-4. And yeah, is spam value true? Flagged. Good. Right. So now we are going to try and find to extract the learning from the salt thing. So this is the conversation about the salts, and are still asked for the same properties. So let's go. Spam should be false. Learning, we should have the learning, and there's no pending question. 2 on 2. Let's go. Now, the last one, we want to detect that there's a pending question. So it shouldn't be a spam. There's still a learning about Saffron, but there's a pending question. And 3 on 3. So it was able to detect that it is not a spam, the learning, and that there's a pending question. So yeah, like GPT-4 is doing like a great job. It's really good at it. The only thing is that it is quite expensive, especially compared to GPT 3.5. So if you're using GPT 3.5 and you move to 4, you're going to experience a 20x cost increase. And at scale, you are definitely going to feel it at some point. So it would be very nice if there was a way to just use GPT 3.5. So we are just going to try the same prompt by changing the model from GPT-4 to 3.5 and see what happens. Hopefully things go the right way and we won't have to think too much. But let's just see. So this is the same prompt on the pizza spam, but we are using here GPT 3.5. Okay. So the spam should be true, but false. Worse even, it's giving a learning about that. Like GPT 3.5 thinks that we should learn how to save time with pizza. Good. Yeah, so not great. Let's see if we have more chances with the pending question. So let's try. Not spam, learning, doesn't even bother including the pending question thing. So it is doing terrible. Like 3.5, like 3.5 sounds great in terms of pricing, but it is significantly weaker than GPT-4. And the more you ask it at once, the less likely it is to deliver. Like here we are asking a bunch of properties at once, but we are also asking it to analyze the conversation and format the answer as JSON at the same time. That's a little bit too much. So maybe, just maybe, if we change the way we approach the problem, we might be able to get something out of it. So maybe, okay, so instead of just asking directly for the properties as JSON, so we are not going to do that anymore. We are going to do a two-step process. So the first one will be asking the questions, like to analyze the conversation. So it's a little bit like a reasoning comprehension test that you will take at school or something like that. And then we are going to use the answers and ask the LLM to format them as JSON. Okay, so we are going to split the work, analyze the conversation first, then use your answer to produce a good JSON. So let's try again. Okay, so we back. We are beloved pizza spam, but this time we are not asking for the JSON directly. We're just asking, hey, here are a few questions. Just answer. What do you think about it? And if we run it, so it says the content of this function is not appropriate. No learning. So it's already looking a bit better. Now we are going to take this and try to format it as JSON with another prompt. So I have my other prompt ready here. So I copy the response. I'm going to paste it here, and run my thing again. So, whoa, it did it. So this time we were able to detect that it is a spam, and there's no learning, there's nothing to learn, just move on. And there's no pending question. So much better than last time. Now let's try with the pending question. So we are going to try again. So this is the saffron thing with the pending question. And this time, we're still going to ask the questions and see what happened. So the content is appropriate, and the last question is a question with no answer. So we are going to take this and hopefully it's going to work as expected. You never know with LLMs, but hopefully it will work. Right, so let's do it. Perfect. Not a spam. It extracted the learning and it detected that it has a pending question. Yep. So this workflow is already much better than just asking directly. And this is the workflow that we actually use on production. And I run it. I run it for our fake community here, and I will show you the reports. So if a small query here just to see, and it was able to detect the first spam. Don't miss out on the juicy whatever fast food offer was a spam. This one as well, this pizza attack, and yeah. So these are the two only spams, and it was able to find the pending question here, and this one also should be a pending question. So I'm going to search it, and yeah, there's a pending question here. So right, and it also extracted all the learnings. So yeah, what can we learn from that? We can learn that GPT-4 is, and mostly like any equivalent model as GPT-4 is high in cost, but you don't have to think too much about the prompt. Like you ask it something, probably is going to get there without too much effort. 2.5, the cost is low, but you have to be really careful about how you approach the problem. You probably also have to split the work into smaller, manageable prompts, and most importantly, let the LLM explain its reasoning. Uh, while with GPT-4, you might even want to be more concise with the prompt to save on tokens. The reason why I insist on letting the LLM explain its reasoning is because LLMs don't usually think before answering. They think while outputting the tokens. So each token changes the probability of the next tokens. So the more you let it explain its reasoning, the more likely it is to make sense. And worst case scenario, if it doesn't make sense, you will see it in the flawed reasoning. So that's a much better approach overall. So like next time you deal with something like GPT 2.5 or maybe a similar model like a Mistral, Llama, or something like that, consider the workflow approach as opposed to just trying to get everything with one prompt. Thank you.
Thank you, Steve, so much. This was really nice. Yeah, everyone is saying great job. Please don't forget to post your questions if you have any. Before others do so, I will ask you a couple of mine, if you don't mind. So yeah, first of all, can you tell me how much time did it take you to come up with a good prompt? Like, how much trial and error was that to get to the point where GPT 3.5 gives you a good enough answer? I'm just wondering.
You won't believe it. It took so much effort. Like
Yeah.
at times you will be changing your prompt and screaming like, "Ah, you're so stupid, GPT 25, do something better." But yeah, it takes a lot of effort to get things right. But if you were able to nail the prompt, it can be consistent. So you just have to be patient and try a lot of things to get to where you want to go. Also
Yeah,
think in
so a
terms of
lot of trial
workflows
and
is
error. Yeah.
yeah, but the idea of workflows is like a game changer.
Mm-hmm. Mm-hmm. And are there any other ways to improve the performance and costs when working with LLMs besides like switching to GPT 3.5? And do you have any suggestions there?
Uh, yeah, so if you want to improve performance with the weaker models, another approach that some people try is fine tuning. So you could take even an open source model like Mistral or something like that, and try to fine tune it. I think with LoRa or something like that, you can fine tune it rather easily without too much resources. And usually it gets a little bit better at a specific task with the fine tunes. There's even a company that has people fine tune things like that. I think they call OpenPipe. So it's another approach to improve performance. Now, if you are spending a lot of money already, you might consider like hosting your own model on a server that you rent or you own. and usually you should be able to get more out of your money.
Yeah, those are really good tips. Maybe someone else also knows from the viewers. Probably they tried a lot with LLMs, so yeah, they might have even better suggestions. Feel free to write it down in chat for the others. But yeah, I really love how you connected properties inside graph databases, how you've shown everything in the community search, and to be able to filter out the spams and show only relevant things. And just for people here that are maybe not that familiar with community search, it's a really great tool that lets you kind of get the knowledge out of your documentation and find the answers to your questions across various everywhere where you have actually the community. So this is really useful so you don't get the wrong answers to your questions, and it's really important to get to the, I mean, correct me, Steve, if I'm wrong. This is just my point of view here.
Yeah, you nail it. That's the idea. And
Yeah, and
yeah, we also, yeah.
you
No,
go.
I was
Sorry,
about
we
to
have
say
a
that.
bit of lag.
Okay. So we also have an assistant that currently uses the docs, but as you saw, that there's potential to also use the community knowledge. So it's a really nice thing to work on, definitely.
Okay. And do you have any general predictions about the LLM landscape? Like, what are your thoughts on this?
Yeah, it's pretty hard to predict what is going to happen. We are getting news or on news every time. But what I think is going to happen is there will be changes. There will be three kind of changes. So let's say two. I think we're going to have more powerful hardware for the same price. And I think personally, currently, the NVIDIA GPUs that are leading the market for that are quite overpriced. I think if AMD is able to pull the firmware and software together, they might be able to compete. And there's and maybe other players as well. So if the cost there gets down, then eventually the cost for all LLMs will be better. Also, I also think that there are um, quite a few improvements to be made on the software side. So there are already some, I think, research on how to improve the speed of inference by using a different approach. I don't know if you saw I think it's called flash attention.
I
It
didn't
is
hear
an
about it.
improvement on the way LLMs perform. Yeah, and there are also new architectures that are being explored, like Member, these kind of things. So a lot of things are going to change and make things cheaper. So probably later in the future, like most definitely, GPT-4 is going to be as cheap to run or equivalent models than the current ones, than the current prices. So these are the links. And I'm going to share the links also to all the chats with as promised. Oops.
Yeah, thank you for sharing those. It's
I,
really
I, I, had
useful,
an,
I think, for
yeah,
everyone.
I had an error, like slow down Shakespeare, too many characters. I'm going to split my links. Wait, seeding fake communities. Uh, so this is a chat with to generate the fake data. Uh, wait, and these are the single prompts to get the properties. Wait, yeah. And finally, the workflow, like the two-part thing. Just keeping my promise.
Yeah, that's cool. Everyone, please save those links so you can check them later. I also told to everyone they can continue the conversation if they have any more questions on Discord as well. Steve is a member of our community, so yeah, I'll tag you, Steve, if I notice someone asks something about it, so you don't have to worry about that. And I think this was
Nice.
another great presentation, Steve. You did a really nice job. I enjoyed it. It was funny again and awesome. And yeah, I think that everyone else enjoyed it as well. I have a lot of awesome, great in the chat. I know you didn't see it all, but I think everyone thought it was great. So thank you, Steve, again for hosting this presentation and for joining the community call. We really do appreciate it, and thank you for sharing your learnings with the community. I think that is really nice. Thank you also everyone who joined.
Yeah, thank you so much for having me like a second time. I really appreciate it. And for everyone that joined, it's really nice to see, and I enjoyed it as well. So thanks.
Yeah, thank you all, and everyone have a nice rest of the day, and see you on the next community call. Bye.
Thanks, bye.